What we have here is a Hartnell electrolysis assembly. You know that water, also known as dihydrogen monoxide, okay, water H2O, pure water is an insulator. Pure water does not conduct electricity. So if you're taking a bath in pure water and someone throws in a toaster, don't worry. But if you got your bath salts and things like that in there, which dissolve in ions and make it conductive, then you're in a big world of hurt when something costs. Fresh water has a bunch of minerals dissolved in there, and especially here, there's also things like methyl bromide and other things dissolved in there from the. What we're going to do is we're going to try and chemically separate the hydrogen and the oxygen from the water. To do that, we've got to force it. We've got to apply some brute force, and the brute force we're going to apply is an electrical current. Since water itself isn't conductive, we've got an electrolyte in there. We have some sulfuric acid in there to help make the solution more conductive, so it will carry the electric current.
Okay, so now we're going to apply voltage. We're going to apply the energy that's required to make the reaction go. And so what you'll probably see is some bubbling. When there's enough current, there'll be enough energy. Oh, 3% seems to work pretty good. Okay, so you'll see the bubbling. You see the bubbling? Can you guys, if you guys want to come up and look at it, I can't take it too far up because it's plugged in the wall. Can you see the bubbles coming up? Can you guys way back there in the corner? Can you see the bubbles coming up? You can come up if you guys want to take a look at it. This is a neat experiment. If I add some more current, it'll happen more vigorously. So we can let that roll. And
so this is one way of producing hydrogen gas.
Want to try it?
Let's go for it.
Okay.
Now we've decided that we think we know which one is the oxygen and which one is the hydrogen, right? Based on the relative volumes. But it's always nice to have a proof positive that what we've got is really what it is.
Okay, well, I guess we'll try and do the hydrogen first. If someone, do you want to hold the bowl? I kind of need two people to do this one. Do you want to be the burner or the collector?
I'll collect.
Okay.
Okay.
All right. Because we have to do it fast. The gas will disperse into the air. We probably should have thought of the collection a little bit better, but go ahead. Oh. Okay. I guess it works pretty well.
That did work pretty well.
So I always call that it sounded like you kicked a chihuahua like that. You could eat them alone. So
What happened? Got a little warm.
you want to try the next one? All right.
Yeah.
Okay. We're going to have a burnt ember. Hopefully this works as good as the hydrogen did. I have to let it burn for a minute. So the oxygen is not going to combust like the hydrogen, but what it will do is it will accelerate the reaction. So I have the glowing ember. You ready? So you see it will relight. See that? So we accelerated the reaction. And normally it would go out inside there. It stayed lit because there was oxygen inside the tube. He inverted the tube because the oxygen is quite a bit heavier than the hydrogen. He kept the hydrogen up because it's lighter, it's less dense than air, it goes up. So we'll play more with density later. So you guys like the demo? Is it interesting?